Good morning, students. In the last period, we have seen the unbanked roads, and we have seen the expression for unbanked road or safe velocity. Today, we will see banked road. To eliminate the demerits of unbanked road, we bank the road. So, what is meant by banking of road? For safer turning, at the sharp turns, the outer edge of the road is raised with respect to the inner edge of the road. That is called as banking of roads. So let us suppose this is the inner edge of the road, this is the outer edge of the road. For a safer turning, to drive the vehicle safely on this turning, the outer edge is raised. It is not horizontal, but it is raised with respect to the inner edge of the road. That is called as a banking of roads. So banking of roads is defined as for safer turning at sharp turns, the outer edge of the road is just raised with respect to the inner edge of the road. That is called as a banking. And what is meant by angle of banking? The angle made by a road surface with the horizontal, that is called as angle of banking. It means if it is a horizontal line, this is a horizontal line, this is a horizontal line, and this outer edge of the road is just raised with respect to the inner edge of the road, then angle made by a road surface with the horizontal, this angle is called as angle of banking. So, in case of banked roads, how these demerits in the unbanked roads are eliminated. In case of unbanked road, accidents may happen due to the insufficient centripetal force. Because that safer velocity or centripetal force depends upon the frictional force, and frictional force depends upon road conditions. If the road is wet, then frictional force, which provides the necessary centripetal force, it decreases, so its safe velocity decreases. The limit of safe velocity is low for unbanked road. When this vehicle goes along the sharp turn on unbanked road, then due to a lateral thrust, there is an excessive pressure on the outer wheel, and by bursting the outer wheel, this vehicle may topple down and accident will happen. Or another reason is that when this vehicle crosses the speed limit, that is, its speed is greater than the safe velocity, then the lateral thrust acting on the vehicle is greater than the centripetal force, and this vehicle will skid in outward direction and accidents will happen. All these probabilities to happen an accident, that is, due to low safe velocity, due to skidding of the vehicle, due to bursting of outer tire, due to uplifting of inner tire, all these possibilities of accidents are minimized in case of banked roads. How these possibilities are reduced? As this road is banked, that is, outer edge is raised with respect to the inner edge, the line of action, this line of action will be shifted toward the inner wheel, and there is an excessive pressure on inner wheel. It means this lateral thrust acts inward direction, and there is no excessive pressure on the outer wheel. The pressure on inner wheel is greater than the pressure on outer wheel, and as this vehicle moves along the banked road, this centrifugal force shifts the load of the vehicle from inner wheel to outer wheel. Let us suppose this load of this vehicle is 1 ton. Normally, on plain horizontal curve road, half ton is on this wheel, half ton is on this wheel. If the road is banked, what happens? The 0.75 Newton is on this side and 0.25 Newton, that is ton, is on this side. 0.75 ton, 0.25 ton. Net weight of the vehicle is 1 ton. It means in case of banked road, load is shifted on inner wheel. As this vehicle moves in this direction, centrifugal force acts on this vehicle and the load from inner wheel is shifted to the outer wheel, and at safe velocity, at optimum velocity, load on inner wheel and outer wheel will be the same, that is a 0.5 ton. It means there is no excessive pressure on inner wheel or outer wheel, so there is no possibility of bursting the tire. So in this way, this demerit is eliminated in case of banked roads. And second one, the skidding of the vehicle, as this outer surface is elevated at higher level, this vehicle will not skid in outward direction, or its skidding tendency is prevented. In this way, this skidding tendency is reduced, skidding tendency is prevented, bursting of outer tire, this possibility is reduced, and all other possibilities, uplifting of inner tire, all these possibilities due to which the accidents may happen, all these are reduced. That's why banking of roads is essential. Banking of road is very, very essential to increase its speed limit. So, we will see the expression for safe velocity on banked road. Let us suppose this vehicle is moving along a sharp turn on banked road. What are the different forces acting on the vehicle? That is, the weight of the vehicle is acting in a downward direction. Normal reaction is normal to the surface. This normal reaction, the reaction which is perpendicular to the surface, that is called as a normal reaction. It is resolved into two components, n cos theta and n sin theta. That is n, this normal reaction is resolved into two components, n cos theta and n sin theta. N sin theta is directed toward the center of the circular motion, and n cos theta balances the weight. At the same time, the frictional force between rod and tire is acting in this direction. This frictional force also provides the necessary centripetal force. It means in these cases, there are two forces which provides the necessary centripetal force. One force is n sin theta and another force is a frictional force between rod and tire. So this is a frictional force and this one is n sin theta. This combinedly both n sin theta and Fs provides, that is component of Fs, that is the Fs cos theta, provides the necessary centripetal force. So in this figure, a normal reaction and frictional force is resolved into two components. This normal reaction n is resolved into two components, n cos theta and n sin theta. At the same time, this frictional force is also resolved into two components, Fs cos theta and Fs sin theta. And W is equal to mg is in this direction. So this combinedly n sine theta and Fs cos theta, these two forces, they are directed toward the center of circular motion, so they provide the necessary centripetal force. So necessary centripetal force for the circular motion is equal to n sine theta plus Fs cos theta. So this is the necessary centripetal force. From this figure, we can write here n cos theta is equal to Fs sin theta plus W. And W is equal to mg. W is equal to n cos theta minus Fs sin theta. So W is equal to n cos theta minus Fs sin theta, but W is equal to mg. So this is equal to n cos theta minus Fs sin theta. So this is for centripetal force and this is for weight. Taking the ratio of these two equations, centripetal force is mv square by r and weight W is equal to mg. We have taken the ratio of these two equations is equal to n sin theta plus Fs cos theta divided by n cos theta minus Fs sin theta, where Fs is the frictional force. Divide by n sin theta. Here m will get cancelled, and on this side divide numerator and denominator by this term n cos theta. It means we will divide n sin theta by n cos theta, that is Fs cos theta by n cos theta, then n cos theta by n cos theta, and Fs sin theta by n cos theta. And the equation will be, on dividing equation will be n sin theta upon n cos theta, Fs cos theta upon n cos theta, n cos theta upon n cos theta, here Fs sin theta upon n cos theta. Here n will get cancelled. Here n cos theta will get cancelled. Here cos theta will get cancelled. So here Fs upon n is equal to mu, that is coefficient of friction. Fs upon n is equal to mu. Here Fs upon n is equal to mu, and sin theta upon cos theta is equal to tan theta. So here sin theta upon cos theta is equal to tan theta, plus Fs upon n is equal to mu. Here n cos theta gets cancelled, that is ratio is 1, minus F sin theta upon n cos theta, that is Fs upon n is equal to mu tan theta. And this Rg goes in multiplication, that is Rg. So V square is equal to tan theta plus mu upon 1 minus mu tan theta in the bracket gr. So this is expression for V square. So coefficient of friction mu is negligibly small, so it is neglected from the expression. So this mu is negligibly small, this mu is negligibly small, or approximately tends to 0. As this is a 0, this tan theta plus mu will become tan theta, and 1 minus mu tan theta, as mu tends to 0, this mu multiplied by tan theta also tends to 0. So this mu tan theta is a 0. So what will be the equation? V square is equal to tan theta into gr, or V is equal to, taking the square root, V is equal to root of Rg tan theta. This is an expression for safe velocity on banked road. So to find the angle of banking. To find the angle of banking. So, if we rearrange the terms, that is squaring this equation, if we square this equation, V square is equal to Rg tan theta, then this Rg is taken on this side, then V square Rg, V square upon Rg is equal to tan theta. V square upon Rg is equal to V square upon Rg is equal to tan theta, and theta is equal to tan inverse of V square upon Rg. Theta is equal to tan inverse of V square upon Rg. So this is expression for angle of banking. So these both terms, that is a safe velocity or optimum velocity and angle of banking, in both equations the term mass of the vehicle m is absent. So we can say that, so what is the note here? Safe velocity and angle of banking both are independent of mass of the vehicle, whatever may be the mass of the vehicle. So angle of banking is the same for same safe velocity. So it will be same for light vehicle and heavy vehicle. So this, as a safe velocity is constant, angle of banking is constant. As the safe velocity is changed, angle of banking. It also depends upon radius of curvature and acceleration due to gravity. It means angle of banking depends upon safe velocity, radius of curvature and acceleration due to gravity. So in this case, what is the important thing? This safe velocity for this road is independent of the coefficient of friction. That is, the role of coefficient of friction in the safe velocity or roads is reduced, is eliminated in case of banked roads. So banked roads are essential. So in this banked roads, the possibilities of accidents are minimized. It doesn't mean that accident will not happen in case of banked roads. Only the fact is that in case of banked roads, the safe velocity limit is increased. If a plain horizontal curve road is designed, if this is a plain horizontal curve road, and on this curve the safe velocity limit is 40 km per hour. So without making any change or just we raising the outer edge, it means road is banked, its a safe velocity can be increased to 60 km per hour, 70 km per hour, 80 km per hour, 100 km per hour on changing the angle of banking. It means in case of banked roads, the limit of safe velocity is high, as well as the probabilities to happen an accident, these probabilities are minimized. ॲक्सिडेंट होण्याच्या शक्यता याच्यामध्ये कमी असतात. ॲक्सिडेंट होतच नाही असं नाही. याच्यामध्ये सेफ वेलॉसिटीवर या व्हेकलवर असणारं जे लॅटरल थ्रस्ट आहे, ही लॅटरल थ्रस्ट 0 असते. म्हणजे हे व्हेकल बाहेरच्या दिशेने खेचलं जात नाही किंवा आतल्या दिशेने खेचलं जात नाही. हे बँक्ड रोडमध्येच असू शकतं फक्त. म्हणून रेल्वे ट्रॅक हे परफेक्टली बँक्ड असतात. रेल्वे जर टर्नवरवर जात असेल तरी त्यातले पॅसेंजर्स हे आउटवर्ड डायरेक्शनला पुल केले जात नाहीत. त्याचं प्रमुख कारण आहे की रेल्वे ट्रॅक हे बँक्ड असतात. आणि रेल्वे ट्रॅक जर बँक्ड नसते तर त्या रेल्वे ट्रॅकवर इतका प्रचंड सेंट्रिफ्युगल फोर्स ॲक्ट झाला असता की रेल्वे ट्रॅक हे उखडून पडले असते. म्हणून रेल्वे ट्रॅक हे नेहमी बँक्ड असतात. रोड मात्र हे बँक्ड असतील किंवा नसतील ते शक्यता याच्यावर अवलंबून आहे. त्या रोडवर अवलंबून आहे. रोड काही बँकडी आहेत, काही अनबँकडी आहेत. फक्त बँकड रोड काय सांगतं, बँकड रोडमध्ये तुमच्या ॲक्सिडेंटच्या पॉसिबिलिटीज कमी झालेल्या आहेत. म्हणजे तुमचं स्किडिंगमुळे ॲक्सिडेंटची पॉसिबिलिटी कमी झाली, बस्टिंग ऑफ आउटर टायरची पॉसिबिलिटी कमी झाली, अपलिफ्टिंग ऑफ इनर टायर ही पॉसिबिलिटी कमी झाली, टॉपलिंग डाऊन ऑफ द व्हेकल ही पॉसिबिलिटी कमी झाली. या सर्व पॉसिबिलिटीज कमी होतात. पण जर का तुम्ही या बँकड रोडवर सुद्धा तुम्ही तुमची सेफ वेलॉसिटी लिमिट क्रॉस करून जर हायर वेलॉसिटीनं व्हेकल चालवत असाल तर परत त्या सर्व पॉसिबिलिटी प्रेझेंट असतात की ज्या ॲक्सिडेंट होण्यासाठी कारणीभूत आहेत. म्हणजे बँकड रोडवर जरी तुम्ही सेफ वेलॉसिटीच्या वर जर गाडी चालवायला लागलात तर स्किडिंग ऑफ द व्हेकल होईल, टॉपलिंग डाऊन ऑफ द व्हेकल होईल, बस्टिंग ऑफ आउटर टायर होईल, अपलिफ्टिंग ऑफ इनर टायर होईल. म्हणून हा जो रोड बँकड रोड, it behaves as an unbanked road if we cross the limit of safe velocity. तुम्ही सेफ वेलॉसिटीपेक्षा जर जास्त वेगानं जर व्हेकल याच्यावरनं चालवलात तर हा बँकड रोड सुद्धा अनबँकड रोड सारखाच बिहेव होतो आणि ते सर्व दोष त्याच्यामध्ये निर्माण होतात की जे अनबँकड रोडमध्ये आहेत.